So DNS, the world's biggest distributed database, the name system that's the backbone of the internet. So today, I'm taking a look at the different open source software packages that I could use in my own network for DNS, and some of the different features that they have, and one reasons you might want to choose one over the other. If you're interested in running DNS on your networks, then come along on this adventure. So before I get started on installing all these DNS servers and testing them, let's talk just a little bit about what DNS actually is. Now, most of you probably know you type the address in the address bar in your web browser, it figures out the IP address of the server hosting it through DNS. Now yes, that's what DNS does, but really what DNS is a protocol for asking for information from a database. Now that information is usually in the form of IP addresses, and the names of those records are the DNS names. But it doesn't have to be IP addresses. We can also put text in there and other stuff. And there's other protocols that use DNS records as their stuff. Also, there's a couple different roles for DNS servers here, whether we have authoritative name servers, recursive resolvers, forwarding resolvers, caches, things like that. So being aware of what role we want the DNS server to play in our network is also very important, because some of these softwares are really good at one role and not others. But anyway, what exactly is a DNS query, and how does DNS distributed database work? So to help us out here, I'm going to use a tool called dig. I'm going to ask it a query. So I'm going to ask the server 2620 FEFE. Don't worry about that one just yet. I'm going to ask it for www.applard.net. I'm going to ask it for a record of type quad A. So dig is my command. I'm asking this server for this name, type quad A. And I get back, let's see what we got. So we got applard.net, 3600 in quad A, 2801, etc. So that is my answer. So you can see I asked a question. I asked for applard.net in quad A, and I got back an answer. applard.net in quad A, etc. So in this case, 2620 FEFE, that's the server's whose IP address I typed in, it was able to resolve the tree of DNS, figure out the record I wanted, which was a quad A, and give me the result. Normally when we think of DNS, this is what we think of. But this is not actually how it works. Also, some little sidebar here, that IN means class internet. When DNS was developed, there were other classes you could use, like type chaos, for example. Some resolvers use those for like status information, so that's fun. But pretty much everything you're going to see is class in. It doesn't mean it's like inside, it's literally internet class. So what does the actual DNS tree look like? So this time I'm asking a slightly different question. So I'm still asking a question of www.applard.net type quad A, but this time I'm asking a different server. I'm asking 2001 7FD1. And what does this server tell me? Well, it gave me a hell of an answer section here. So it said, I asked in my question section, www.applard.net in quad A. And it said the authority on that domain is part of net. In that case, I need to ask these servers instead. So it's basically telling me that it doesn't know the answer here, but it knows that I need to ask another server, in this case net. And here are 13 servers I can ask, gtlservers.net. And it was also very kind enough to give me those 13 servers' IP addresses. This is called the additional section. So it gave me their IP addresses here. I could then go use these and figure out the query. So fundamentally, DNS is a tree structure. So every time we make a query, every time there's a dot in the query, that's an opportunity to be redirected to a different server that has more information than us. So DNS doesn't just magically go in one huge database somewhere. Instead, it's a tree. So we start from the top of the tree, which is the root. This is where all the top-level domains are stored. So com, net, edu, I happen to have a domain on .fi, the country code top-level domains. All that these root servers know is the top-level domain servers. There's a couple hundred of those, and each of them are distributed dozens of times, etc. Then net has to know our domain. So I own applard.net that's registered through net. So the server that operates net has to know applard.net. Then from there, www is by my own server, applard.net, etc. So this goes down all the way to make a tree. So if I run the server at appleR.net, I can put all of my sub-records in there on my own server that hosts that. So what does it look like to fully recurse this tree? So coming back from this query, I want to figure out www.appleR.net in quad A. And the root server here, 2001-7FD1, told me I have to ask net. In this case, I have to ask gtldservers.net A through M. So I'll just pick an arbitrary one of these. So we'll just copy this guy, 2001, 502, etc. So let's rewrite my query to ask him. So now I'm going to ask this guy, m.gtldservers.net, the same question. So I'm asking a new server, same question. So he gave me back again. He again doesn't know, but he says appleR.net has 3 name servers. They are helium.ns.hetzner, hydrogen, etc. So I now got to figure out what these guys are, and he also didn't give me any glue records. How rude of him. Okay, so this is the guy I got to ask now. So let's ask him my query again. So 2001, 67C, 192C, add 5. And he has my answer, 2A01, 4FF, F0, etc. So this process of starting with the root server and working our way down is called recursing. We're recursively searching from the root down until we get our answer. So in this case, I happen to know the IP address of the root servers. They're just well known. We know that there's 26 addresses, 13 IPv4, 13 IPv6. I typed one of them in. It then told me I have to ask the authoritative servers for net. It gave me their addresses. I asked net. Net then told me I need to look at an NS record, so it's called a name server record in DNS. Instead of a quad A or double A, it's an NS. And so in this case, it told me I had to go to helium, oxygen, hydrogen at Hetzner. So I asked them. They were then the authority on my domain, appleR.net, so they could give me an authoritative response. Hence, the servers that I queried now are all called authoritative name servers. So if we're running some website in public DNS, most people nowadays are probably just asking their hosting provider to do this. But what this is you're hosting DNS that is the authority on a domain. Now this domain name server should be publicly accessible on port 53 to everyone, and it should not accept queries that it is not the authority on. So what happens if I were to ask this server something else? So this, for example, is the Helium server. What if I ask it, instead of appleR.net, what if I ask it google.com? What's it going to give me? So in this case, it told me status refused, because it is not the authority on google.com, so it's not going to answer my question. But looking back again, what if I try my recursive server again? So 2601 FE. Sorry, 2620 FE. It then gave me the answer. So the answer is there, it's just that the Hetzner server up here didn't want to tell me what it was. So that's part of the security model of DNS. So we really have 3 different types of servers in DNS. We have the authoritative name servers. These ones hold the original records. They're the ones I've been querying now. The next ones we have are the recursive resolvers. This is a server whose job is to go down the tree on behalf of other nodes. And the third type we have is called a forwarding resolver. This one does not go down the tree. It just forwards queries to someone else. So usually when you think of DNS, you think my computer reached out to a DNS server to get the DNS, just the cloud. That is either a forwarding server or a recursive server, but in any case, it's handling the whole query for us from top to bottom. Some server somewhere has to query the root server, query the net server, query all the way down this tree to figure out what the heck this name is that I got to return. And so that's going to be the recursive resolver. If we don't want to run a recursive resolver on our network, we can run a forwarding resolver. Pi-hole, for example, is only able to act as a forwarder, not a recursor. So those are the different pieces of software we're looking at in this video. How good are they at forwarding? How good are they at recursing, the client side, asking the questions? And how good are they at being an authority, answering the questions? Now, most people in most networks use the authoritative and the recursive role very differently. So the authoritative role in most people's networks, if you're not hosting stuff publicly, a lot of people use the authoritative role to host stuff internally. If you do split horizon DNS, you have names that only resolve internally. That's the authoritative side. You're the authority within your network, within this little subdomain you've carved out. The other side is recursing. I have clients on my network. Most clients don't recurse on their own. Some can, but most of them are going out to a forwarding server. So my clients on my network are looking for a server where they can ask any question and get any answer without having to go down the whole tree. Now the downside of making this public is now you can be used in what's called a DNS amplification attack. Your query will get hammered. If basically you ask a question that's small, that you know gets a big response, you can cause the denial of service for other people, amplifying the amount of traffic. So you don't want to be a public DNS resolver on the internet. Unless you're authoritative, then you must be public. So very often in large organizations, you'll have two completely separate servers for this role. Today I'm kind of mixing that all up. This is my internal network. I'm not doing authoritative stuff publicly, so that's the role I'm looking to fill today in this video. So I guess the question to answer now, down here in the lab, is what software should I talk about in this video, and what software should I not? So there's quite a lot of different pieces of software out there that do DNS, that do authoritative name serving, recursive resolving, forwarding. I made a little list on my phone I'll read off for a second. If you're running like a hosting, doing authoritative name serving for the public, there's really only a couple choices you have. So Bind9, that's like the classic. NLNet NSD, that's the name server daemon for authoritative name serving. PowerDNS has an authoritative server, which is different from their recursor, by the way. Technidium can do authoritative serving optionally. If you're into the Kubernetes world, CoreDNS is kind of big there. That's pretty much the options you have. There are some more niche options, but those are the authoritative name servers. Next up, I have the recursors. These are the guys that start from the top of the tree in DNS and work their way down. Now, technically, a client could do this on their own if they wanted to, but realistically, no client does. They're all forwarding upstream. So that's why we as network operators have to run our own recursor. So our options here, again, Bind9. I don't know anyone who's actually running, like happy about running Bind9. I know a lot of people do run it, but there's probably better options out here now. Unbound is by NLNet, the Dutch research group. They also do NSD, the name server daemon. Unbound is their recursive resolver. It is very popular. Technidium has the option of doing this again. PowerDNS. It's a separate program for PowerDNS for authoritative versus recursive. Totally makes sense. Great to separate those two things. Now, realistically, what most of you guys are running at home is not a recursor or an authoritative server. It's a forwarder. This takes in DNS requests, checks its local cache to see if it has them, and if it doesn't, it goes on to another server. And that's all it does. You configure the upstream, you point at it downstream, caches, that's it. Super basic. Most of you are running this at home. The three examples I have here are DNS Mask. Now, DNS Mask is used in a wide variety of like home, small Soho, small office routers. So if you're using your ISP provider router, it probably runs DNS Mask. DNS Mask is very good at this, but it's not particularly featureful software. Pi-hole is also strictly a forwarder. And AdGuard Home, those are two web UIs that do like ad blocking DNS, which is the thing I think a lot of you clicked on this video for, so I'm going to touch on it, of course. But it's a bit of a different side to actually hosting DNS recursing or hosting DNS authoritatively. So those are all forwarders that continue on upstream. Now, some of the reasons you might want a forwarder is because there's actually like 6 different protocols you can run DNS queries over. So the actual DNS protocol itself is officially defined to be on TCP and UDP port 53. Now it does include TCP. A lot of people think it's just UDP, but that is not true. You can always query either TCP or UDP. Some clients will query TCP properly. Some won't. Some will just do UDP, but whatever. So we have UDP 53, TCP 53. We also have DNS over HTTPS, that's port 443. We have DNS over TLS, which is not encapsulated within HTTP, it's just DNS TCP within TLS. That's on port 843. Also have DNS over QUIC, which is the same thing as DNS over TLS, but using UDP-based QUIC instead. There's also DNS Crypt and a couple other less popular extensions. But basically the ones you'll see will be classic DNS, UDP TCP, DNS over HTTPS, DNS over TLS, DNS over QUIC. So 5 protocols there. I also had a poll on this and what people think about DNS over TLS or HTTPS or etc. I think a lot of you have misunderstandings over the security in DNS. So most people are worried, a lot of people are worried about their ISP snooping their traffic. Probably because a lot of ISPs actually do snoop a lot of traffic. So one of the ways that you could prevent this is with encryption. However, encryption in DNS is not focused on protecting the privacy of the packets on the wire. It's about ensuring the authenticity of the records. So DNSSEC, what most people think of as DNS security, because that's what it is, DNS security, is about making sure the records are correct and authentic and haven't been tampered with. So you're not being redirected to some different address. So with DNSSEC, you're signing the records to guarantee that they're authentic, but you still not guarantee that someone can't look at the record. So if you send a query to your ISP using DNSSEC, your ISP could still watch that you sent that query. You just know the ISP hasn't tampered with the result you got back. So it's useful, but it's not privacy sensitive. So for that, a lot of people used something that tunnels their DNS, such as DNS over HTTPS, TLS, QUIC. Now, that's not, it is a standard, but it's not something that public authoritative servers will run. So generally, they're only running UDP 53. So this would mean that our client would have to go through a forwarder or through a resolver that supports the secure interface on the back end. So that's one reason a lot of people now are switching from doing their own recursive resolving with Unbound to doing forwarding to a place like Quad 9 over TLS, because that way everything leaving our network is secure with TLS. The downside there is that instead of recursing ourselves, we have to trust a recursor somewhere else. So there's trade-offs there. Also, we can take a look at all three of the softwares. I'm really deep diving this video thanks to this video sponsor, the Blackview DCM6 dual monitor laptop extension. So this guy here, it's two 14-inch 1080p panels. They hook onto the back of your existing monitor, so it makes a triple monitor setup. In my case, I've got a MacBook Air M1. They've included all the cables I need to hook us up and get two extra displays here, so I can look at Technidium, Pi-hole, and AdGuard Home all at the same time. Not that I would want to be stacking 3 DNS servers deep, but I could with this setup. It's possibly more useful to me since I'm in the process of moving to Finland. I can do video editing on here. I can use my main display as like a video out, put like toolbox on one side, editing queue on the other, etc. Whatever I'm doing. I got plenty of monitors for it. Maybe I'm doing CAD. I do a lot of CAD with the robotics kids too. Maybe I can put some reference photos on my side monitor, CAD on my main monitor, something like that. Now if your laptop supports dual display outputs, they have all the cables to hook up to 2 Type-C ports and take displays. They also have cables to hook up to HDMI. In my case, since the MacBook can only do one external display, I got that hooked up to the right side. They included a USB display driver for the left side. Great on that. It can also pass through power, so I got it plugged into power here. It's powering my laptop, charging itself. I'm pretty happy about that. So Blackview DCM6, 14-inch, triple monitor setup, 2 extra monitors for your laptop. Pretty cool. Link down in the description below. So to help you guys out a little bit, I made a graphic of all the different server software that I know of and which protocols they support on the client side. So this is accessing from your users to your DNS server on your network. Now it's very clear all of them support classic DNS, obviously. Pretty much all of them support DNS over TLS, mostly because this is commonly used as an upstream protocol and for zone transfers. However, DNSMask and Pi-hole don't, so maybe they're a little bit behind on feature set. Now DNSMask is intended for low memory footprint routers, that totally makes sense, and Pi-hole is stuck using DNSMask, so I guess that makes sense for them too. We can also see that the DNS crypt protocol is pretty much dead. The other thing to note here is that DNS for TLS support is actually not that common among end clients. So most of the time, if you're configuring a protocol that's not classic DNS on your end user's devices, you're going to be pushing something like a config to Chrome or Firefox to tell them to use encrypted DNS, and they only support DNS over HTTPS. So if that's something you care about, you'll need to look for that DNS over HTTPS column. If you're hosting multiple servers, doing zone transfers between them, like having redundant pairs or stuff, DNS over TLS is probably what you want for that. DNS over QUIC is a new feature that should start replacing DNS over HTTPS long term, but I haven't deployed it yet either. So I'm pretty much just looking at DNS, classic DNS support for my clients. So when I'm running my network, my DNS server is within my network. So I am doing firewalling and stuff to access this DNS server. I'm not particularly concerned about the security of my DNS queries over my own network. I run my network. I know who's snooping on it. I know I'm using good encryption on Wi-Fi. See my videos on Wi-Fi encryption before. So someone would have to work pretty hard to access my DNS queries. So I'm serving my clients classic port 53 UDP DNS. I'm telling them over DHCP, over RDNSS, this is what they should be using. So for me, this chart is not particularly useful. However, I know a lot of people go absolutely wild over this shit, so I made the chart anyway. Next chart, features for each DNS server. So these are just the features that I am particularly concerned about running my networks. Again, if you're an ISP or you're running like hosting provider networks, you're gonna have very different needs than me. So these are for client networks, like I mainly manage. So the first question you have is, do you want to resolve or not resolve? If you want to do your own resolving, then there are essentially only 5 options for you. Bind9, NLNet Unbound, PowerDNS Recursive, Technidium, or Not Resolver. However, pretty much all of the other ones here have a setup guide online on how to front it with Unbound to make Unbound do the resolving. So if you want to use Pi-hole, AdGuard Home, something like that, many people run those and then have it forward right into Unbound so that Unbound can do resolving, and this other thing can do whatever it does better than Unbound. Now, Unbound is really, really good, so a lot of you probably will want to just run Unbound by itself, especially because it's built into OpenSense. OpenSense is my favorite firewall. But there may be other considerations. Maybe you don't want to send your recursive queries to the internet, so you want to run a public resolver. In that case, you'll be doing forwarding anyway, and this won't matter to you. Now, the next feature that some people think they need is split horizon. Now, how well this is implemented varies a lot for some of these options. I put them down as a check mark. Some of them have much more granularity in how you can pick what clients to send where, what subnets, etc. Some make you write individual rules for each domain separately or things like that. However their config layouts are structured, they're at least capable of doing something. Now, most of you probably don't actually want to run split horizon DNS. You want to just have a resolver that resolves only locally within your network. But since you're not exposing it to the internet anyway, it doesn't really matter if everyone who queries your internal server gets the same internal result. You know what I mean? Now, a thing that I think will be a showstopper for a lot of you is if they have a web UI. A lot of people that follow my channel probably don't care that much about having a web UI, but it does make for some really pretty graphs. And so a lot of people that are less knowledgeable about DNS are probably going to be picking a solution with a web UI. So for there, you essentially have only 3 options: Technidium, AdGuard Home, and Pi-hole. Now, these were the 3 options that really started this video, was a comparison between those 3 in this role, because those are all so popular for client-side resolving to run those 3. And one of them is just clearly so much better than the other 2. But those are the 3 with the web UI. PowerDNS also has a third-party web UI, but I didn't count that because it's third-party, so take it with that way you will. Now, the most important feature for me personally is the ability to do individual DNS rewrites. So I am not hosting full zones on my server, and that's an option if you want to, like host an entire zone locally, like home.applr.net, something like that. Most people are taking DNS domains and they're overriding them on their local network to point to local resources. That's a very common way of doing it. It's a common way these configs are structured. So essentially your DNS server will initially have a list of all the servers on your local network and what their names are. And if you query one of those, you get back that response. And if you don't, they forward it on, they resolve on. Now for AdGuard Home and Pi-hole specifically, I put this as partial because they're very limited in what query types they can override. So AdGuard Home can only override A, Quad A, and CNAME queries. So you can't add NS records, you can't add text records, things like that. Now I don't want to be too hard on AdGuard here. I am personally using Unbound on OpenSense, and OpenSense's web UI only supports A, Quad A, and CNAME also. So I can't add text records, pointer records, etc. on Unbound, but that's not the fault of Unbound, that's the fault of OpenSense's web UI. So sorry about that. The last one I have is the ability to do local forwarding. This is where you take a domain and forward all queries to that domain and the subdomain to another server. That doesn't mean you're rewriting the result. It means that you're taking the whole query and sending it on to another domain server. So this means I'm hosting that zone somewhere else. So to be able to do that, we have to be able to rewrite domains or forward conditionally based on what the domain query was. We don't have support for this in Pi-hole. We do have support for it in basic DNS mask, so you could write an override config for Pi-hole using its underlying DNS mask, etc., which seems kind of stupid to me. And so, given the needs of my home lab and my network, I'm trying to serve classic UDP DNS to my clients, do encrypted upstreams to a DNS resolver somewhere else. In my case, Quad 9 is my resolver of choice. I have chosen to take a deep dive into 3 for this video: Technidium, AdGuard Home, and Pi-hole. I think these are the three solutions that most of you will actually be considering, and the other ones are either more academic or not really for a network of your scale and your resources. Or they're mainly just authoritative servers, which most of you aren't running anyway. If you're in a bigger network, a lot of these would be a better choice for you, but just taking a look at these three today. Okay, so now that I've narrowed down my choices for what I'm going to recommend as a DNS server for your networks, granted that you're not medium to large enterprise or internet service providers, I have 6 basic tasks, things that I would like to do with DNS on my networks. I'm going to see how easy it is to do them with Pi-hole, AdGuard Home, and Technidium. I've also got a basic Ubuntu VM that's going to be my test client so we can abuse it. So let's jump in, and we're going to start with basic DNS overrides. So first off, I'm in Technidium here. So I'm going to go to my zones. I don't have any zones created, so I got to add one. We're going to add a zone where we're primary, and it's going to be palnet.net. That's what I use internally. Don't autocorrect. So sorry to whoever actually owns palnet.net. I've been using this internally for like 10 or 15 years. I don't think they're using it publicly, but I haven't bought it from them. So sorry. But essentially when I create a zone like this, it's going to handle all records in palnet.net. So I can't just override individual addresses this way in Technidium like you would in, say, AdGuard Home or Pi-hole. But I think this is the best way to actually do it, to create a whole zone for yourself, or like home.domain.net, whatever. So I'm going to do add a record. I'm going to call him Voyager. He's a quad A. I don't know, we'll give him a lifetime of 60 seconds with an address. And go ahead and save that. So that should be good to go now. Yeah, so I got to ask for a quad A, but yeah, there it is. And what do you know, it's my caddy welcome page for a test system. Now if you're unfortunate enough to have to do dual stack as well, we can also add an A record for him. Not that I need it, but let's go ahead and add that. Save that. So my quad A still comes back, and my single A also comes back, no problems. Hypothetically, if I had 2 servers that were both hosting this resource and I wanted a load balance, I could do that as well. So I can say Voyager, and we'll make him 191. So now I ask again, and I got 2 answers. Easy. So pretty sure it's just going to go downhill from here for the other 2 guys, but let's see if we can set the same thing up with AdGuard Home and Pi-hole. So AdGuard Home, I'm in here with quote-unquote protection. So let's go into our settings. Oh, filters. Filters, DNS rewrites. Okay, so we are going to rewrite Voyager.palnet.net, and it's going to be that A record. We're going to do that again for the quad A. Save. Okay, so we have both an A and a quad A. Let's see here. We got the A, and we got the quad A. So now can I add a second one? Say I have 2 this time, 8FF instead of 8FE. It allowed it, okay. And we got both back, okay, so that works. So AdGuard Home, pretty easy, pretty basic function, and it did it just fine. Some Pi-hole, by the way, it's down under local DNS records. Add, can I add a second one? It allowed it. So we got the A, and we got both the quad A's. Okay. Okay, so all 3 of those could do basic DNS overrides without too much trouble, at least for A records and quad A records. How about something a little bit more complicated? Can I redirect a whole domain to a different name server and still have it query? So imagine that I'm here in the US, home.palnet.net, but in Finland, where I also live, if Migri ever processes my paperwork, maybe I have koti.palnet.net. So every time I get a query that is part of koti.palnet.net, we should redirect it to that server over there instead of trying to host it locally. So what would that look like? So that server is already working here. It's got this address. We'll ask it for the server Matti, and we get back to AO1 Beef Cafe. So over here in Technidium at the higher level zone palnet.net, and go here and I can add an NS record. So we'll say Koti. So this is the record, but we're also giving it that name, which we don't, I guess, have to do. And let's save that. So now if I ask that same question at Technidium, I get back the same answer. But it recurses to get that answer. Now the question is, how do I get AdGuard to do that? So if I say rewrite Rewrite all responses with a star. That's not what I want. I want you to recurse. Okay, so I have to put it here using that syntax for specific domains. Okay. Okay, so I got an upstream just for that domain pointing to Cody's name server. This time, instead of asking Mati, we'll ask Maya. And we got to AO on Facebook. Good. And so finally, what about Pi-hole? Can Pi-hole do this? Not here, but is it going to be under this thing again, upstreams? So I only have the option of defaulted to v4 only quad 9. Well, it looks like the answer here is I just can't do it. So not there, not in custom servers. Obviously, it's not one of the defaults, and I can allow or deny it, but I can't really rewrite it. So I guess Pi-hole just can't do it. So unfortunately, Pi-hole was not able to complete that last test, so mark against Pi-hole. Next up, we're going to try something that's basically the only reason anyone ever uses Pi-hole. That's for ad blocking. So I got an ad block tester I found on the internet. Let's see what it does. So this is me with just basic quad 9. So quad 9's malware filter blocked 11 of these guys, I guess. So let's switch over to Pi-hole and see what Pi-hole can do. Okay, so try again. And you got a much higher number this time. 69%, is that our total? Nice. Final result was 71%. Not bad. Over here on Pi-hole's page, we can see that it did, in fact, block some queries just now. And testing again with AdGuard Home. What are we at now? 96%. That is very impressive. And again, AdGuard shows stuff has been blocked by filters. Nice. So Technidium is wildly configurable. So I did a quick search of the internet for what block lists are people using with Technidium. I found someone's example config and I dropped it in. I have done zero work to tweak this block list. I found someone else that provides block lists on GitHub, picked their most aggressive one, and we're going to try it on Technidium. So I have done a minimal amount of work here. Let's see how it goes. Again, 96%. Again, 96%. And over here in Technidium, you can also see some stuff has been blocked. Okay, so the one thing that everyone loves Pi-hole for, it's not even all that good at. Now again, the Pi-hole community probably chose a less aggressive list as their default because they're sick of people installing it, not knowing how to tweak it, and then breaking things. So a less aggressive list as default makes sense, but I don't see any reason for anyone to be using Pi-hole when AdGuard Home exists. And for people that are in the HomeLab space, even that is pretty basic compared to Technidium. But I still have 3 more tests left to do. So where are we going from here?
One eternity later.
Okay, so my next trick I was going to show off was DNS service discovery. This is like adding printers that show up with unicast DNS instead of dicking around with multicast relays or stupid things like that. However, it is devilishly hard for me to set up, even me, who's done this before and got it to work in the past. So I am not going to do that now. I'm going to go on to the next trick, DNS 6.4. I already know this is going to be hard for Pi-hole, but let's see what we got. DNS 6.4. This is basically for setups using like 464 XLAD or NAT 6.4. You can see my Taiga video for more on that. I'm the lead developer of Taiga now, by the way, so I love NAT 6.4 technology. Basically, this lets our clients, which only have an IPv6 address, to access the IPv4 internet by translating all of their A records into quad A records. So over here in Technidium, I can go to Apps. I can go to the DNS App Store, and I can install DNS 6.4. There we go. So now, using this, I can specify what prefix we should get. In this case, it's not going to rewrite these 3 address ranges, 10, 172, 192, but it will rewrite everything else. I'm going to actually get rid of this one because I do want it to rewrite those. But yeah, let's see what happens. So this particular server here has an A record, as we can see. But if I ask it for a quad A now, I get translated with DNS 6.4, just like that. So AdGuard Home. AdGuard Home is not the worst. Does it have options to do this in, can I do a custom filtering rule? Not looking good. Yep, nope, not looking good there. Pretty sure we know what the answer is going to be like in Pi-hole 2, but maybe we got options. Yeah, no, it's not looking like we have options. Okay, so if you want to use DNS 6.4, got to use Technidium. A lot of the other servers that I didn't look at also support DNS 6.4, so Unbound can do it. OpenSense supports an Unbound config to do it natively. It's pretty easy to set up there if you're using DNS 6.4. I'm expecting a lot of you probably won't be running DNS 6.4 that wildly, but it's a feature that I make heavy use of, so it's important to me. The last thing I'm going to look at is query logging. What ability do we have to actually inspect what's going on and troubleshoot some errors? So just to see what's going on here, I'm going to type in a query that is spelled wrong, appler.nut. What do I got back? I got an error, NX domain. But let's see what that looks like in the log file. So over here in Technidium, I went to apps, the App Store, and I downloaded query logs SQLite. Expecting most of you are not running a massive server, so SQLite will be fine for you. If you're doing something wild, you can do MariaDB instead, or like horror of horrors, Microsoft. But SQLite for me. So now I can go to logs, query logs, and let's say, well, everything is kind of not no error. In this case, we'll say NX domain. See what's going on there. Yeah, so here's someone queried appler.nut. We get some people querying as.buzzilla.org.palo.net. What the hell are they doing? Oh, because it was blocked. Interesting. So over here in Edgard, we have a dashboard which shows just very wide statistics. If I click on this, I can see everything that's been processed just in all time, which is kind of cool, I guess. But if I want specifically things that were blocked, I can look at that too. Or things that failed. Do I have the option of... Okay, so there's rewrites. Do I have ones that were like NX domain? Okay, so it shows up as processed. I guess that's what it means when it didn't allow it, or it had some weird error, I guess. I don't know. But it's in the log. And Pi-hole. If I look at my query list, can I actually look at this? Hello? Clients. Logs. Do you have a log? It shows up here. It shows up as green, which it shouldn't because it failed. Oh, serve from cache. Reply NX domain. Yeah, that's an odd way of writing an NX domain is green, but it is a log. Okay, so hopefully this video has enlightened you on some of the different options you can use for hosting DNS on your own network. Now, where you should go from here, I think depends on what you're running right now and what you hope to get out of it. So opening this discussion, I do not rely on DNS for ad blocking. I only use essentially malware blocking lists, not advertising blocking lists. For ad blocking, I rely on client-side, AdBlock Plus, things like that. Since I use Firefox, Google hasn't killed them off in Chrome because I use Chrome. So that's what I do. I'm not relying on something like Pi-hole or AdGuard Home to have a finely tuned block list. Now, if you're running something right now that runs DNS mask, you're probably not going to like it. So if you need to do customization, the kind of stuff we do in the home lab space, the kind of tests I did earlier in the video, they're not that easy to do in anything based on DNS mask. That includes Pi-hole, which maintains their own fork of DNS mask for stupid reasons. So that basically means if you've got a router provided by your ISP, or you're using like an all-in-one router Wi-Fi access point, it's probably running DNS mask. Or if you use Unify, I believe they use DNS mask as well, probably going to have a bad time. Now, if you're using something that's based on Unbound, so OpenSense, for example, is based on Unbound. Unbound is a fantastic resolver, and OpenSense's UI, well, it doesn't expose all of the features of Unbound. I think it exposes enough for most home lab people to be very happy with the features provided in OpenSense. You can do A records, quad A records, CNAME records. You can do not exactly NS delegation, but you can forward queries for specific domains, specific places, using their upstream, similar to how we did at AdGuard Home. You can do all that in OpenSense, and that's pretty much what most people need. Now, if you need to do pointer records, serve records, the stuff you need for DNS service discovery, you can't do that. but I don't think that's nearly as common as A records, quad A records, CNAME records, stuff like that. So you can do all of that in Unbound in OpenSense. OpenSense also supports DNS over TLS upstreams. Now generally, I use DNS over TLS upstream to Quad 9. So that's my upstream. I'm acting as a forwarder. And to my clients, I serve standard UDP to TCP port 53. So again, I am on my network. I am managing the security of things on my network. I have decided I don't want to encrypt DNS traffic over the wire because I'm sufficiently happy with my access controls to my network. So I am not running DNS over HTTPS, over QUIC, over TLS, downstream to my clients within my network. Now, some people, of course, have different opinions on this. That's what I do. So port 53 downstream from Unbound, and DNS over TLS, which is port 853, upstream. That's what I run. Now, if I needed anything more advanced than that, the only place I'd be looking would be Technidium. On, again, a network of this scale, the Homelab size, you're not trying to scale out like if you're an internet service provider. You need something that scales very well. I don't think Technidium is particularly scalable to that sort of scale. Then you're probably going to be running something like Unbound manually anyway, which is fine. You can do that. But if you're running small, medium business, Homelab stuff, Technidium is a great answer for those use cases, I think. You have full control over all the different DNS records that are possible. It can act as an authoritative server, but I wouldn't want to do that at scale again. But for internal stuff, I think it's perfectly great for that. So that's my conclusion here. I think AdGuard Home has a place for being very easy to use and install. So if you just want something quick and easy for ad blocking, I'd pick AdGuard Home. I honestly don't know why Pi-hole even exists anymore. AdGuard Home is better at it than everything. They're using a fork of DNS mask that they maintain for who knows what reason. So if you're using Pi-hole over AdGuard Home, I'd love to know why in the comments. If you're using either of them over something better, is it because you just want ad blocking, or do you actually want more customizable DNS features, stuff like that? Now, I'm Applard, by the way. I just launched a new merch store, link down in the description for that. You can buy shirts like this beautiful one here. Cloud-free is the new luxury. Friendly reminder to log out for self-care. Now, if you like self-hosting stuff like me, maybe you like to rep that with a cloud-free shirt like this. It's available in gray and orange for this design. So link down in the description for that. If you want to chat with me, I have a Discord server, link down below for that as well. That's where we talk about all kinds of stuff like DNS, things like that. What else? I have a Mastodon. If you want to follow me there, it's kind of like the Deadbird site, but it's a Mastodon instead of a bird, and you toot instead of tweet. And I also take donations on Ko-fi, but I'd rather you buy a shirt or something like that so that you get something out of the deal. But you can also just give me tips there if you want. So, as always, I'll see you guys on the next adventure.